starting with 3.5, they start talking about a directed line segment. Now, everything we have learned in the past has said that a line segment has no direction, right? Right? It just has two endpoints, okay? A directed line segment does have direction. It would be like me walking from here to the office. Obviously, I'm starting here and ending there, correct? Okay? A directed line segment would be something similar to that. So here, it's a directed line segment AB, meaning I'm starting at A, ending at B. Okay, so there is a specific direction here. A is at 3, 2, and B is at 6, 8. They are asking us to find the coordinates of point P along this directed line segment so that the ratio of AP to PB is in the ratio of 3 to 2. Okay, so I'm going to add a point P on this line segment somewhere so that AP to PB is 3 to 2. To me, the easiest way to think about this, and the last classes have kind of agreed, let's think about this as I'm walking from point A to B, but I'm taking a pit stop at P. Okay? So if I'm walking from A to B, I'm telling you that P, to get from A to P, I'm walking 3 miles. And then after I stop and I go from P to B, I'm walking 2 more miles. Does that make sense? And so I have a total of how many miles that I'm walking? 5. Okay? To get that, I would add these two, correct? Mm-hmm. Okay. So the first 3 miles, I'm taking a stop. I'm trying to figure out where am I stopping at. Okay, that's my goal here. So, the first thing we have to do to be able to do this is we have to know the slope of line segment AB. What is the slope formula?
Mx plus b.
That's slope-intercept form. That's the equation of a line. That's what we did yesterday. Just slope formula.
M equals the square root of y1. Or is it just rise over run?
You're thinking distance. It is rise over run, but what's the equation? What if I can't just count rise and run?
X 1 divided by
1. X2 minus X1.
You have to know that. I took your chapter 3 test yesterday that you're going to take on Tuesday, and I took your benchmark that you're going to take on Thursday. And I promise you, you need to know the slope formula. And you can take my word for it, or you can wait and find out for yourself. That's up to you. But I would suggest you learn that if you don't know it. Have that memorized. What is y2?
8.
8 minus
2
over
6
3 minus 3. So 8 minus 2 is 6 over 3. Now, this is one thing we're going to do here different than what we usually do. Usually that means the slope is 2, right? Up 2 over 1. Okay? Don't reduce it. Because if you reduce it, we're not going to be talking about the whole line segment. Because what this is telling us is to get from A to B, I need to go up 6, rise 6, and run 3, right? Okay, if I reduced that to 2 over 1, I wouldn't get to B, right? I'd get to like here. Does that make sense? Mm-hmm. So don't reduce that. We want to get all the way to B. Okay? We okay there? Okay. Now, how far, thinking of this, how far, and I'm going to get this out of here because this is just going to get in my way of what I want to do next. what is the fraction of the length to P over the whole length?
3 out of 5.
3 out of 5. You guys understand what I was saying there? Well, I couldn't think of a good way to word that. But to get to P, I need to go 3 out of the whole 5, right? Okay? So I'm going 3/5 of the way, correct? Okay? So I need 3/5 of the rise and the run. Does that make sense? So what I'm saying is to get from here and to rise the same up to P, I need 3/5 of my total rise. Okay? So I need 3/5 of 6. When I do the run, I need what?
3/5 of 3.
I need 3/5 of 3. Okay, we all agree on that? It's 3/5 of the way, so I need to rise 3/5 of 6, and I need to run 3/5 of 3. What does the word of mean in math?
Divide.
Multiply.
Alright.
Of means multiply. So, what we're going to do is we're going to take our slope, and up here I'm saying I need to multiply 6 times 3/5. So I'm going to take 6 and I'm going to multiply times 3/5 because I need 3/5 of 6 as my new rise. How much of my run do I need? 3/5 of it. Okay. We multiplied fractions yesterday. How do I take 6 times 3/5?
6
You
over
have to turn
1.
that.
You can figure that as 6 over 1. So then I take 6 times
3.
3, which is
18.
18, over
5.
1 times 5, which is 5. Now here, the easiest way to probably do this is change this to a decimal. And I'll do this one for you just because I know a lot of you don't have calculators in front of you right now. But in a calculator, you would just divide them, right? Change it to a decimal. Okay, 3.6. Okay, now, was that my rise or my run?
Rise.
Does the rise go with the x values or the y values? The y values, because my y-axis goes up and down, right? Okay, so I know that this belongs to my y values, correct? Okay, so now taking 3 times 3/5, 3 times 3 is 9 over 5, which equals, you would change that to a decimal as well, which is 1.8. Okay, that was my run, correct?
Yes.
Does that go with my x's or my y's?
X.
That with my x's. Okay, so what we just found out, we haven't found our new coordinate point yet, but what we do know is that to go from A to P, I need to rise 3.6 and I need to run 1.8. Okay? So that is going to be adding to where I'm already at. So my new x value, instead of 3, my x is my runs, right?
So it'd be 4.8.
So I'm running from 3 and an extra 1.8, which is 4.8. Good, you add them. And my rise was I was at 2 and I went up 3.6. 5.6. Now you have your coordinate of where P would be at. So there's lots of stuff going on there, right? Okay, we're going to do another example. I'm going to see if you can guide me through this more than this last one. Okay. Our second example They use C and D this time. And point C is at negative 4, 5. And point D is at 8, negative 3. And we are trying to put point F on here so that CF to FD is in the ratio of 3 to 5. So I guess 3 to 5 would probably be somewhere closer to here. Where am I starting at?
C.
Okay. They're going to put them in alphabetical order, okay? They're not going to try to trick you and say it's a directed line segment ZW. It'll be WZ. Okay, they're going to put it in alphabetical order for you. Okay, so we're starting at C, we're going to D. How many, if we're talking about walking, how many total miles are there this time?
8.
There's 8 total. I'm going 3, taking a break, and then going the last 5. Okay? I need to figure out where F is. Dylan, do you remember the first step? Find my slope. Exactly. So, find our slope. So, y2 is
Negative 3.
negative 3. Could I use 5 if I wanted to?
Yeah.
Yeah, you can flip them around. It doesn't really matter. Negative 3 minus
5.
5 over
8 minus
8
minus negative 4.
minus negative 4, which is actually
Positive.
plus. On the top, negative 3 minus 5 is
Negative 8.
negative 8 over
12.
12. Don't reduce it though, because if you reduce it, you're not getting all the way from C to D, right? Okay. So we want to leave that. What fraction do I need to multiply my rise and run by to get to F?
3 over 8.
3 over 8, because to get to F, I need 3 out of the whole 8, correct? Okay. So I'm going to take my negative 8 over 12, and I'm going to multiply the top, just like you guys said, times 3/8, and the bottom times 3/8. Okay. So negative 8 times 3 is
24.
negative 24. 1 times 8 is 8. What does that reduce to? Negative though, right? Negative 3. Okay. Bo, is that my x or my y portion of that slope? That'd be my y, because that's my rise, right? Okay, so this is my y. Okay, 12 times 3 is 36 over 8.
It's 3. It's your X. Oh, it's not
What is that?
36. That's
4.5. Okay, and that's, like Emma just said, that's my x, right? Okay, now that's not the coordinates though. What do I need to do with those two things, you kind
Add.
Uh-huh.
So we'd add. Hang on.
Well, this is my x, right?
Right.
So I
you
should
add
add that
to
too.
the x, then you
Yep.
add it to y.
So my x used to be
4 point. No, wait. Be.
used to be
Oh,
negative 4, right?
Yeah.
And I'm adding,
4.5.
so I get
8.5.
well, that's negative.
Should be negative. No, wait.
Negative 4 plus 4.5 is? What's negative 4 plus 4?
0.
Plus another half. 0.5. So 0.5. Now be careful with that. I'm pretty sure if you type in just 0.5 on Big Ideas, I'm pretty sure it counts it wrong. You need to put 0.5. Okay? Dylan, how do I get my y value? I guess I already called on you once, huh? Paul, how do I get my y value?
Take 4.5, or my bad, negative 3, and divide by.
So to get my x, I took negative 4 plus 4.5. So to get my y,
5
and then,
plus negative 3,
which is
8, or
negative. Careful.
negative
5.
would be negative 2. Positive.
Positive, because 5's
Yeah.
the bigger number is positive, right? So
Yeah.
5 plus a negative 3 is positive 2. Okay, so there's my coordinate point. And like I said, a lot of that's new, just in there's so many steps. But we've done slope before. You've used slope formula before. Okay, we're just using it in a different way. You will have time at the end of class to try one of these while you're still here. So if we're struggling still, you'll have another chance here in a while. Okay? Now, the next thing that we have is the two theorems that you needed to write down. Slopes of parallel lines is the first theorem. And I'm not going to go too far into this because what do you know about slopes of parallel lines?
The same.
They are the same. They're equal, right? Okay, so I'm not going to go into that theorem. We should already know that. The next theorem is slopes of perpendicular lines. I'm also not going to go into that because we know that slopes of perpendicular lines are
The same.
how'd you do it yesterday on your explorations? What did you use for perpendicular lines?
Oh, you took the reciprocal and changed it to negative?
Opposite reciprocal. Okay, we better touch on that, I guess. What's the opposite reciprocal of 3/2?
2 over 3.
Negative 2/3. Those two slopes would be perpendicular. If those were slopes of two lines, those lines would be perpendicular. Okay? We have to know that. Slopes of perpendicular lines are opposite reciprocals. Okay, that's what that theorem tells us. Okay? Now, if you take a look at example 2, it says determine which of the lines are parallel and which of the lines are perpendicular. Does it give you the slopes in the diagram? A lot of you probably have no idea what I'm talking about because you don't have your books open. No, they do not give you the slopes. So are you going to have to find the slopes?
Mm-hmm.
Yes, that is the only way to figure out if the lines are parallel or perpendicular is if you find the slopes. Okay? So, you should be able to do that using slope formula. Okay? Now, if they give it to you on a nice coordinate plane, could you count the slopes as rise over run?
Yeah.
Yes, that's okay. I'm okay with you doing that. Hey, I do that all the time if I can count it. You still have to know slope formula in case they don't put it on a coordinate plane though. Yes. Okay, so you still need to know that. So let's say we went through and we found all the slopes. Line 1 was 3/5. Line 2 was 3/8. Line 3 was negative 5/3. And line 4 was 3/5. Are there any lines there after we found the slopes that are parallel to each other? 1 and 4. They have the same slope, right?
Mm-hmm.
So line 1 would be parallel to line 4. Are there any others that are parallel?
1 and 2.
1 and 2 are parallel?
No.
parallel lines. Then no.
3 over 5 and 3 over 8, right?
Yeah.
Okay, are there any that are perpendicular?
3 and 4.
1 and 3 and 3 and 4.
1 and 3, 3/5 and negative 5/3. And what was the other one you said?
3 and 4.
3 and 4. Negative 5/3 and positive 3/5. Okay. That's what you're going to have to do on those problems that go with that example. Okay. Except you would have had to solve and find the slopes by yourself. Okay. Think we could handle that? Alright, flipping over, example 3, writing equation of a parallel line. You just did that yesterday. You should be able to do that. If you can't do that, you need to come talk to me, because we need to figure out how to do that. I promise you, you have to do it on your test and benchmark. Example 4, same thing, write an equation of a perpendicular line. Okay, you should be able to do that, and you have to be able to do it on your test and benchmark. Okay. Now, real quick, before we move on to the last example, if I have an equation that looks like this, and I'm trying to write an equation of a line that's either parallel or perpendicular to it, that doesn't look exactly like what we did yesterday, right? Okay, it's in a different form. Can I put that into slope-intercept form, though?
Mm-hmm.
Yes.
How?
Subtract 2x to the other side.
Moving the x to the other side, getting the y by itself, right? Okay, if you just do that, then you have y equals negative 2x plus 12. Now this is in a form that you are more used to. The other form is standard form. Okay, it's still an equation of a line. It's just written differently. It's not in slope-intercept form. Okay, if you put it into slope-intercept form, you will most likely have less struggles. Okay, so just be aware of that. You will run into that on your assignment. Okay, last example. And this one is actually longer yet than the first example. So pay close attention. There's many more steps than we've had to do in the past. So what we're trying to do here is they give us a line and a point that's not on the line. So the line is y equals negative x plus 3. And the coordinate point that they give us is 1, 0. They want us to find out how far that point is away from the line. I believe it was 2 days ago, we talked about when you're measuring the distance from a point to a line, there's something special that we have to make sure we do. What was that?
Make sure that the segment you measure is perpendicular to that line.
Make sure the segment that you measure is perpendicular to the line. So, the first thing I would suggest doing is drawing another line in there and showing yourself that it is perpendicular here. Okay. So what we are trying to do is we are trying to figure out how far is it from this point to this point, right? Do you agree with that?
Mm-hmm.
What's the problem?
You don't have another coordinate point.
I don't know that other coordinate point. If I knew the other coordinate point, I could use distance formula, but I don't. Okay? We have to figure out what that coordinate point is. Okay, you guys have done this in the past, that you, in Algebra 1, and actually we've touched on it a little bit here in geometry, we have had two lines, and we found out where they cross. It's systems of linear equations. You have two equations, and you solve for x and y. Okay, we've done that, and you did a lot of it last year. Okay, but do I know the equation of my blue line right now? No. Do I know how to find the equation of a line that's perpendicular to another line though? Yes, that's what you did yesterday in your explorations. Okay. So, when I set up the equation for my blue line, what does the slope need to be if my slope of my black line is -1?
Positive one?
Opposite reciprocal, which would end up being +1. Okay? So my equation is going to be y equals +1x plus, do I know what my y-intercept is? No. So I'm just going to leave it as b. Okay, so this first step that we're going to do here is exactly what we did yesterday in our explorations. Okay? How do I solve for b?
Do you put 1 and 0 in for the y and the x?
Put the x and the y from my coordinate point in for x and y, right? Okay, that's what we did yesterday. So my y is 0. My x is 1 plus b. Move the 1 over. b equals -1.
Okay.
Okay, just like what we did yesterday. So the equation of my blue line, after I plug this back in, is y equals x -1. That's step 1. Find the equation of your other line. So my other line is y equals x -1. Now we also need to figure out that coordinate point where they cross, right? The solution to a systems of linear equations is where they cross. It's a coordinate point. So I need to figure out what is this x and this y right there. Okay? Since this is y and it equals this, is it okay to take this part, -x plus 3, and plug it in right there? That's exactly what we need to do. That's how we're going to start our systems problem. Okay, so I now have -x plus 3 equals
X -1.
x minus 1. Good. Okay, so I substituted that in there. Should I be able to solve for x now? Yeah, so let's combine our like terms. Let's solve for x. To do that, I need to do what with this x? Add it to the other side. So I get 3 equals
2x.
2x minus 1. Then add the 1. So I get 4 equals 2x. So x equals
2.
2. So if x equals 2, what does that tell us? What did we just find right there? The whole coordinate point?
No, just for
Just x.
Just the x value of our coordinate point. So I now know that this coordinate point has an x value of 2.
So can we
How do I find the y value?
plug it in?
Plug it into what? Which equation? Yeah, it doesn't matter which one. Plug it into either one. I would go this one just because that one has a negative. So 2 minus 1 is
1.
So my y value must be 1. Okay. Now, so far we've done a lot of work on this problem, right? Are we done yet? What was our main goal? What were we trying to do?
Find the distance between.
Yeah, trying to find the distance. So are we done yet?
No.
Not yet.
Now we need an
Now we have our 2 points. Now we need to find out how far apart they are. So we use our distance formula. What goes in our distance formula? Okay, which would be
Let's say 2 minus
2 minus 1
Square.
squared plus
1 minus 0.
1 minus 0
Square.
squared. That diagram now does not matter to us, because I've got everything I need. I know when I'm done solving this, I have my answer. So, 2 minus 1 is
1.
plus 1 minus 0,
1.
1 squared. And I know you might not do all these steps, but I just want to show it. 1 squared is 1 plus 1 squared is, so I have the square root of 2. Now, I believe on your assignment they're going to ask you to round to the nearest tenth. Okay, that's approximately 1.4 units. Do we all know how to turn that into a decimal on our calculator? Just type it in, right? Okay. Make sure I'm right on that. Yeah, 1.4. Okay. So that's a ton of work just to get to that distance. Okay, but that's the only way, without a ruler, to get there. And you're probably not going to get to 1.4 units on a ruler accurately. Okay, let's do one more of those. Okay. So let's try, I'm finding the distance from the line y equals 2x minus 4 to the point of 6, negative 2. Sophia, do you remember the first thing we did? What did we draw first?
A line.
Our other line. And when I draw it, it has to be perpendicular here. Okay. And what we have to do to be able to find this distance is we have to come up with this other coordinate point so we can do the distance formula, right? Okay. What do I need to know before I can come up with that point? What's our next step, William?
Slope intercept form for the
I need slope intercept form for the blue line. Okay, I need the equation of that line. I know that that line is perpendicular to y equals 2x minus 4, so the new slope is going to be
Y equals negative 1 over 2.
negative 1/2 x plus b. Now I go through everything we did yesterday, I solve for b. Okay, so the x value that I'm going to substitute in is 6, so I'm going to have negative 1/2 times 6, and my y value was negative 2 plus b of negative 2 equals, what is half, or what is negative half of 6?
Negative 3.
Negative 3. And then
Add 4. Add 3.
add 3, and I end up with b equaling
5.
No.
1, right? Because I add 3, negative 2 plus 3 is 1. Okay, so my equation is y equals negative 1/2 x plus 1. Okay, so this equation down here is y equals negative 1/2 x plus 1. that was only step 1 though, correct? I'm gonna drag this up a little bit this way. Have a little more space. Okay. Now what did I have to do? Now that I had that other equation, why did we need that other equation?
To make the payments for that combination.
So I can plug it in for y on the other equation, right?
Yeah.
Okay. So let's do that. So now I know that this is what y equals, so I can put it right there. So I have negative 1/2 x plus 1 equals
2x minus 4.
2x minus 4. You guys okay with moving this over here?
Yeah.
Okay. But I don't have a common denominator right now, correct?
Correct.
Okay. I want to leave this as a fraction. How can I write 2 with a denominator of 2?
4 over 2.
4 over 2. So now, when I add the 1/2 x, that goes away, and I add the 1/2 x. On the left, I still have 1. But what is 4 halves plus 1/2?
5 over 2.
5 halves minus 4. Move my 4
5.
by adding or subtracting?
Add.
Adding. So I end up with 5 equals
2.
5 halves x. How do I, because right now I have to divide by what technically? I'm dividing by
5 over 2.
5 halves, right?
Yeah.
Okay, I gotta divide by 5 halves to get x by itself. How do I divide by a fraction
You have to take the reciprocal
and do what with it?
and
Multiply. I have to take the reciprocal and multiply. So those cancel. On the left side, I have times 2/5. 2 times 5 is?
10.
5 times 1 is?
5.
5.
So I have 10 over 5, right?
Yeah.
Which is equal to?
2.
2. So 2 equals x. What did I just find there?
Part of the
Part of my coordinate point, the x value, right?
Yes.
Okay. So the x value of my coordinate point must be 2.
Always plug it into any equation.
Plug it into any equation, find the y. I would choose the top one just because that has a fraction. Shouldn't be too hard, but sometimes it will be. So I have 2 times 2, which is
4.
minus 4,
0.
which is 0. So the y value is just 0.
Gotcha.
Okay. So now that I have that coordinate point, my last step is to do what?
Distance one.
Distance formula. Because I'm trying to find this distance right here. So I have the square root of
That's 6 minus
6 minus 2
2. Squared.
squared plus
Negative 2 minus 0.
-2 minus 0 squared.
Minus 2.
And 6 minus 2 is
4.
4. And 2 minus 0 is
Negative 2.
negative 2 minus 0. And 4 squared,
16.
16 plus negative 2 squared,
4.
4 square root of
20.
20 total. Okay, which again, if they wanted you to turn that into a decimal, that is approximately 4.5 units, which you would be able to do on your calculator. Okay, so you can see why I'm not giving you a homework quiz over this tomorrow, right? Okay, there's a lot going on here. Okay, I would call these the most difficult problems we've probably done, just because there's so many places to mess up. Okay, what I need from you for tomorrow is you need to complete problems 3 and 21. It's one of each of those, example 1 and example 5. Okay, you need to have those done. When you get to class, I will submit your assignment and make sure they are done. If they are not done, you will get a 0 for today's participation. Everybody understand? Okay. I would recommend to you, after doing these problems, to work on that middle group of problems where you're finding equations of parallel lines, equations of perpendicular lines, those examples we skipped. Does that make sense? Because you should be able to do those. Tomorrow in class, you will have all class to work on this assignment. Okay? And then, so hopefully, if you do all that, all you'll have left is the hard problems from example 1 and 5. And I want you in here to do those in case you have questions. Does that make sense? So for sure, get problems 3 and 21 done. Those are required. Okay? I want you to go ahead and start on those.